everything. So there's actually two open source program online on Android market called the Bluetooth Chat and the BlueTerm. So we basically, went over the program, got some ideas, how Bluetooth works, how to connect with them and everything. But there were some problems that we found, with the app. So for our purpose, we needed to connect to the Bluetooth module. For the Bluetooth Chat program, it only communicates with other Android devices that have Bluetooth Chat app on it, and the BlueTerm program, the code was like very long and it's like hard to follow everything. So we didn't have enough time to go over and understand everything. So. This is before we get started to make our Android app, we made a state diagram of Android application. So just have a flowchart to have basic idea of what we would need and what we need to program and everything. So as Rafael mentioned before, the first thing we need to do is called onCreate, which basically initialize all the variable and IDs. And then we needed to have some program to make connection between the Bluetooth module. And after making pairing with the Bluetooth, we wanted to have a couple of buttons. So there's a status button. When you press the status button, it will send certain data over the Bluetooth to the microcontroller that requesting the status of the LED. So the microcontroller then send the data back. So we need to think about all those. Like this is just basic flowchart that we had. And so at first we need to connect to our Bluetooth device. So to program that, Android actually had this Bluetooth APIs. Basically the APIs allows you to scan for other Bluetooth devices, and it tells you how to connect with them, pair with them, and then transmit and receive data. So the Bluetooth adapter is what makes your Android device discoverable and scan for other devices, and then it calls the instance Bluetooth device, which is basically your the Bluetooth module will be in here, and it will request a connection. Then it will request a connection through the Bluetooth socket API, which will then connect to your Bluetooth module and allow you to transmit and receive data.
This is a flowchart or state diagram for the microcontroller part. We have to design this because when we're designing the Android application, we realize that Android is more easy to update, and when we'll code for the microcontroller, it will be sitting in there and it will never update them. So we thought it would be more nice to have more flexibility to our Android application rather than having more flexibility toward the microcontroller. So we ended up designing a flowchart how the microcontroller will communicate with the Bluetooth, so that even in future, if we update our Android application, it will still be able to communicate with the microcontroller, because the microcontrollers follow the Bluetooth application requirements. So there will be no problem even in future if we update application many times. Now there are some basic steps when we developed our Android application. For example, the first step was to communicate with the just to receive from our microcontroller, because that was the first requirement, that whenever the light intensity of LED module will goes below 70%, it will transmit the data that it goes below 70% and let the user know. So our first aim was to create a button that will send the data to microcontroller, and after receiving the data from the Android application, the microcontroller will transmit the data that if it is went below 70% or is it still above 70% or 50%. Now, after we completed that status button, that it working fine with the Android application properly, we should start adding more buttons and more stuff. For example, turning on the application and turning on the Bluetooth LED light, or turning off the LED light, or any other electrical device inside the room. Now, this is the final version of our Android application. When we turn on the application, it will go to a splash screen. This will show this screen for a couple of seconds, and then it will go to this screen. It has two buttons. One is a status button, and one is a light state button. The status button when you press the status button, it will show the state of your LED light intensity. And when you press the light state button, or there it could be any other button, just to show the status of any device in your room, or even the LED light module. If it is on, it will show it is on. If it is off, it will show it is off. The benefit of this thing is, as we mentioned, there are some Bluetooth module that can actually have a range of 100 meters. So if you're sitting in two or three rooms in one room, you don't know if what is happening in that room. You can use this application to see which devices or which electrical device is on or off. If you want to turn it on, you don't have to go to that room and turn it off. You can just sit in that room and check for the state of each device and turn it off and turn it on. And after that, this is a further expansion, because as we said, one of our first aim was to get the data from microcontroller to show in our Android application that what is the state. After we accomplish that, we choose towards the further expansion that we earlier mentioned, having abilities to control any electrical device in a room. There are many relays in the market. Some of the relays are solid state, some of them are mechanical. Our application can work with both. It just needs a little modification. And it can, using this application and relays, we can remotely control any electrical device inside a room.
Well, I just want to mention that we actually, initially we chose the solid state relay, but when we actually bought, we bought a couple of them. When we bought them and when we tried to implement it, we found that it was always shorted for some reason. So there was like always the 120 volt, AC always going through. We didn't know why. So then we went on to the mechanical relay, and we implemented our project with the mechanical relay. So this is a schematic, basic schematic, showing how it works. So these are the two pins that are connected to the AC, and so when you send a control voltage, which is roughly 3.7 to 5 volt, this line will be shorted, so the 120 volt AC will go through.
This is just the final testing of our Android application. After we made our application, we tested it, and it was working perfectly with our Bluetooth module and with our microcontroller and their microcontroller. We don't have any problem with receiving data and transmitting data. It can communicate with either microcontroller. So they can have any kind of microcontroller as long as it has a valid UART and baud rate. It can communicate with our Android application properly.
And this was actually the diagram we were missing. This was the final power supply that we implemented. We just had transformer, and those are the two voltage regulators that we mentioned.
When we designed the Android application and the relays, we realized that the possibilities that it opens is a lot. As we mentioned earlier, it can control any electrical device in a room. Not only any electrical device, it can actually control any microcontroller that is sitting inside that room. What I mean to say, it can create a hierarchy of microcontroller, and we can have one single microcontroller with a single Bluetooth to control any other microcontroller inside the room. So so we need only one Bluetooth to control any electrical devices or any other microcontroller sitting in that room, so that we can get data from them or transmit data to them. So which means if we have, like, for example, if we have 7 or 8 LED boards that has microcontroller into it, we don't need 7 or 8 Bluetooth module to communicate. We can just have one single Bluetooth module and a single extra microcontroller to communicate with all of them, which can reduce the expenses. And this microcontroller can also control any other devices that they will have inside the room, for example, lights, even a fridge or AC or any other things.
Well, conclusion, basically we're successfully able to make our final product, which will detect the light intensity and notify the user through either the app, or there's a display or blinking light that it's below 70% or above 70%. And the expansion of our project, since we finished our main part of the project, which was just detecting the 70% of the light, we went on to the Android application. And basically were successful in making it, which would just display your 70% of LED and tell the user either it's time to replace your whole LED module, or either you have the control to turn on and off the light using the relay we implemented. And there was many possibilities for future expansion, as Russell mentioned.
All right, I want to give a special thanks to Selux Lighting for allowing us to do the project and sponsoring it for us. Specifically, Brian Patterson was the industry group person that we met with, which he was unable to make it today. We have Dr. Gonzalez, who was one of our advisors, and Dr. Azadi, who was our other advisor.
We have the video for demonstration, right?
Yeah, on here?
Gave you the flash drive thing?
And a little demonstration video for you guys. You guys still have a little bit of video.
So this was our sensor part. We for our purpose we use this analog sensor. That's our app. So and that's a relay, and we will just demonstrate. When you press the status button, it will tell you how many percent of the LED it is. As you could see, well, actually first this will be the LED board itself. So when we press on and off, this will turn off this board. We just didn't have it hooked up to it for that demonstration. And when you press the status button, it will show you how many percent of the current status of the LED board is. So as you move the LED board away from the sensor, it will show you that the intensity actually decreases. And when it goes below 70%, it will tell you that this is the time you should actually change your LED board.
I was going to show the whole process, how we save the EEPROM. It actually showed actually saving the data I mentioned earlier. All right, so what you're going to see right here is the little LCD screen that's showing the data. And this is what we use to help troubleshoot and just show the, and so what's going to happen is the idea is to sample the light intensity once a month, but we condensed it down to 8 seconds. We don't want to wait around for a month, so we did that. And what you're going to see is two lines, two rows of information. The top line is going to be the actual light intensity. And the one below is going to show the 70% cutoff. And that's when we receive the data from the sensor, we take that into the process and manipulate it, and then we're going to display it. So what's going to happen is it's going to zoom in, and you're going to see it update. And then approximately 4 seconds later, I'm going to kill the power. We're going to come back online, and you're going to see the same cutoff values we had stored it from earlier. and 4 seconds later, it should update again, showing that, we wrote the EEPROM, and this is for the whole time, the purpose of we're in a time delay for a month long to kill the power. We want to make sure we test it once while it's running for a month long. When it's cut off, we can never work, not worried about that. It's going to show information, and about 4 seconds later, it should update again the top one. And that's simulating the month-long delay. I mean, it's not fireworks or anything, but it's the whole idea to save the information. And every time you kill the power, it stores it, and that's the whole idea of making it reliable. And that's the basic idea. And we have other LEDs on there simulating the cutting off the 7%. That's a little short video. We have it upstairs. If anyone wants to come up here and see it, we can show a lot more things if you'd like to see. This is just a little quick snapshot.
So any questions?
The 70%, was it the company requirement, or is it some kind of a standard, or you just picked it as an example?
What we got, Brian from the company represented